Hi, in this video I'm going to be discussing what scatterhoard is, how it works, and some of the basic commands to get started using it. Scatterhoard is a file archiving system similar to the HDFS file system that Hadoop uses. It's written in Python 3, so it will run on Linux and Windows. Uh, it is agentless, so remote storage locations that you are backing up files to don't need to be running it. The only thing they need is some form of SSH server that has SFTP capabilities. So usually that just means OpenSSH. You you can back up singular files or directories of files or multiple files, and it'll take each one of those files, it will hash them, it will chunk them up into 100 megabyte or less sized chunks and distribute them randomly to storage locations that you've designated. A storage location is just a directory in your local file system, usually one storage location for each physical device. It requires at least 3 of them, and remote storage locations can be accessed through the Paramiko library that is used for remote storage locations. So now that you know what scatterhoard is, let's go over some of the basic commands and setting it up. So first command is the help command. You can issue that either with a question mark or typing out help, and that shows you all the list of all the different commands. And it also, if you type in question mark and then say one of those commands like put, it'll give you a description, what the aliases are, what arguments it takes, and what flags it takes. So you can use it, and it shows you some examples on how to use each one of those commands. So that'll get you started using some of the basic commands. There's also config, and we can see I'm using that database right there. The default database is sctr.db, and all that is stored in the database for this Python script is the metadata for your files and chunks and storage locations that you've assigned. So let's set up a new database. And the databases are just SQLite. You can have multiple databases. Like say for instance, if you have you want to separate namespaces or something like that, you can create multiple databases. And these SQLite databases are easy to back up. They're just files. It's just a file. There is no installation or users or anything like that you have to set up for these databases. They're just basic SQLite databases. Okay, we can see that I just created a new one, and let's go through the first few basic commands that you would need to use to get started using this program. And the first thing you do is you add storage locations, and you do that by issuing the command add storage. So I have a test folder set up here, And normally I have all the storage locations and all the directories I'm going to use for storage locations in a temp directory, but normally you would have one storage location for each different physical device, like a hard drive or USB drive or something like that. And the logic behind that is that it's the same as RAID. You know, if one drive fails, then it doesn't take out all of your storage locations. You only have to replicate what was lost on that failed drive. And scatterhoard has self-healing properties. If you run the scrub command, it will go through. Say if you have a failed drive, you can recreate. You can add another storage location, run scrub, and it will identify which files have less than 3 copies of each chunk, and it will self-replicate those lost chunks. So kind of similar to ZFS, where you got that scrub command. Okay, so let's copy that directory. Okay, so we added that storage location. Oops. Added the second storage location. And you're required to have at least 3. So you have to have at least three different storage locations, because every chunk needs to be stored at least 3 times for redundancy purposes. Okay, so we got 3 of them. We have 3 storage locations set up. So that's all I had to do. I'm ready to start using scatterhoard. Nothing else, no further installation or anything like that. Very simple. So managing storage locations, you can add them, you can remove them, you can show which ones are active, and then when a storage location, the physical device that the storage location is assigned to, if it becomes full, you can set it to read only, so the software doesn't attempt to keep writing data chunks to that storage location. Okay, so let's use the put command. So put, you can either use put, p, or backup. Just use p, and let's grab a file to backup. And let's use the -t flag for adding tags to the file. What the tag is, it's the tag is basically the same as like what you'd use on social media. It's just a descriptive term for that file. So this is just a GIF of a cat that stands up and starts walking on its hind legs. So we can add the tags humor, GIF, cat, and that describes the tag. And what the tags allow you to do is you can search by tag. So if I wanted to find every file in my data set that is tagged with cat, I can do that, and it will result with this file. So you can see This is a small file, so it's only got one chunk, and that chunk has been distributed to 1, 2, 3 storage locations. Now, obviously, you're not going to want to do that for each individual file that you have, so there has to be a way to add a batch or a whole directory. The batch command will go through and it will find every single non-directory file in a directory. It won't recursively go through the directory. I'll probably add that later if there's a need for that. But as of right now, it doesn't recursively go through a directory structure. It only does the non-directory files inside of a single directory. So let's take this folder and let's do P and then -- batch because it's a batch job. Okay, so you can see it gives less information. It doesn't show you where when you're doing a batch job, it only shows you that it's been completed. It doesn't go through and show you where each chunk has been stored. So let's take a look at the files that we've backed up. Show files will go through and show you every single file in your data set. If you have thousands of files, you might have quite a few pages of files to go through, but it shows you all the information regarding the file. So for instance, the file ID. Every file has its own file ID. When you're retrieving a file or altering the metadata of the file in any way, you can refer to it by its file ID instead of the file name. This is useful, for instance, if a file has a very long name with all sorts of weird characters in it that you don't want to type out every single time you want to use it. And every file also has a batch number. So as you recall, we just added a batch or a directory of files. And what that allows you to do is, in the same way that the file ID allows you to interact with a singular file without naming it, the batch number allows you to interact with a whole set of files without naming them. So say for instance, if we wanted to retrieve all the files in this batch, we can just do the get command -b, and that will and then the batch ID, which is 2, or the batch number, which is 2, and it'll get every single one of these files. So you can also use G for get or retrieve. They're all aliases. They do the same thing. So you can see right here, when it retrieves the file and it downloads it or it rebuilds the file from the chunks, it will then hash it to make sure that it was recreated correctly with no bit rot or data errors or anything like that, and then it compares it to the hash that's in the database for that file. And if it's the same hash, it'll tell you that it's been retrieved with 100% data integrity, which is useful. So if in any situation where these hashes don't match, then you know you have bit rot somewhere, you have a failing hard drive, or any number of circumstances that you can take steps to resolve. And in that situation, it's recommended to run a system-wide scrub with the scrub command or the health check command. Those are both aliases as well. They do the same thing. Okay, so now that we have files in our system, let's try searching for them. so you know what files you have. So search, and it does substring searches, so you don't have to type out the whole name of the file. So let's do search. Say for instance, if you're trying to find that GIF of the cat that's getting up and walking, I'll show you what I'm referring to. I think everybody's seen this GIF. So search and walk. So it'll come up with walking cat.gif. Search GIF. Same thing. It's a substring of walking cat.gif. And then search. I remember that I tagged that file with cat. So you do -t for tag, and then cat. And it'll show you those are all the files that I have in my data set that are tagged with cat. So that's very useful. All right, that pretty much wraps it up for the basics of scatterhoard. Let me know if you have any questions or requests for features or anything like that.